All right, electrical conductivity. Electrical conductivity. Sorry, I mumbled there for a second. All right, we're going to deal with acidic acid, potassium hydroxide, copper nitrate. It's a nice pretty blue one. Some glycerin. Sucrose. Oh man, I forgot the sucrose. It's downstairs. It's table sugar. I guess I'm going to be skipping that in this demonstration, but I'm just going to show you folks how to do this. We need some distilled water. That would be here or here. Both of these are distilled water. The 96 well reaction plate. A conductivity apparatus. That would be this thing right here attached to a 9-volt battery. A graduated pipette, small beaker, and a 150 milliliter beaker. Do I need the small beaker? Yep. All right, here's a small beaker. So, the object of this lab is to gain an understanding of conductivity of liquids, to observe conductivity of solutions of salts, strong acids, strong bases, and also that have a high degree of dissociation. We need to observe the conductivity of solutions in weak acids or bases that have a low degree of dissociation, and we want to observe the conductivity of distilled water as it dissociates slightly, and also to observe the conductivity of organic solutions and an organic liquid. This lab is pretty simple to set up. Let's see. What we want to do is first make our table sugar mixture, and to be honest with you, I forgot to grab the table sugar downstairs, but use this. You mix it up with 2 spoonfuls, and then you put 60 milliliters of water in there. And then, actually, wait a second. I probably want to use my 150 ml one, so the bigger cup. It's currently being used with something else, so I'm not going to use that for now, but you want to put 60 milliliters of water inside there. Mix it up, and that will be your solution. Let's see. We also need 5 drops of KOH, so that's potassium hydroxide, in well A2. Okay, A2. 1, 2, 3, 4, and 5. This is potassium hydroxide. In well A3, I'm going to put some acetic acid. That's CH3COOH. 1, 2, 3, 4, 5. In well number 4, I'm putting some copper nitrate. One, 2, 3, 4, 5. And then in the last well, I'm going to put 5 drops of glycerin. Keep in mind the glycerin is a lot more viscous than the other solutions. So you're going to have not a hard time. It's just the drops might come out very slowly. So be patient with this one. 1, 2, 3, 4, 5. Alright, now put the 9-volt battery on the battery tester, which I have, just to check it out, just to test it out. I have some staples, and I'm going to connect this battery tester to that. You see it lit up? That is basically 100% conductivity. So all you need to do is dip this in each slot and observe what the conductivity level is. Try to capture how bright something is, or if there's no light at all, or if it's really, really bright or dim. I know that that's not necessarily the most scientific scale, but I guess you can decide on what happens. And then also I dipped it in one, and then before I dip it in the next one, I don't want to contaminate my thing, so I'm just going to take some distilled water and spray the bottom right there and dip it in another. I'm not going to tell you which one this is. You can take pictures if you want to try to kind of compare the brightness one to another. Here's another one. You can barely see that. And then here's another one. And keep in mind, I forgot to include the sugar water, so that should be in one of those. Oh, that's interesting. That's really interesting. I'm not going to tell you which one that is, because I want you to conduct the experiment yourself. All right, continue to test and record the conductivity of each of the liquids. Be sure to wash the electrodes and distilled water before each test. That's what I just showed you how to do. To clean up, this is such a diluted solution that I can just make sure to use lots of water and dump things into the sink using lots of water. Cleaning up is the most important part of doing chemistry labs as well as cooking, and I'm sure that your mom appreciates, or dad appreciates us saying, hey, clean up after you're done with your work. Okay, I think some of that glycerin is stuck inside of my, in one of my wells, and I don't want it to get stuck there. So I'm going to take this Q-tip and I'm just going to swab it out. There we go. If you don't clean this stuff out immediately, sometimes what will happen, it will just start drying in there, and then it's going to be a pain to get out later. So, anyway, let's throw that away. That's that lab.